Hello, Algebra 1 fam. We are back to finish up Chapter 1, Day 8. So we are on Part 2 of Day 8. And if you remember, when we last kind of talked about this on Tuesday, we were solving equations with variables on both sides. And we had a chance to work through some of those. And the big thing was I reminded you guys that we have steps when we solve these equations. Really, when you solve any equations, you have these 4 steps right here. So you can pause the video and just kind of take a second to reread all 4 of these steps here. And so let's put these steps into practice with one practice problem, just to make sure we're all feeling good about solving these multi-step equations. Let's scroll down and look at number 2 here in the middle of this first page. So again, step 1, deal with parentheses. Well, we have parentheses here and parentheses here. Can't combine those, can't combine those. So instead, that means we're ready to distribute. 2 times 3x is 6x. 2 times 1 is 2. 4 times x is 4x. And 4 times negative 5 is negative 20. Now, you're ready for steps 2, 3, and 4. So 2, 3, and 4. So let's see what you guys got here. So we work this out. We want to, step 2, combine our variables. Well, they're on opposite sides of the equation, so I'm going to subtract 4x over. Since it's a positive, I've got to get rid of it. Subtract it over. That gives us 2x. Then, step 3, I want to combine our regular numbers. We got a 2 here and a negative 20 here. I'm going to subtract the 2 over because, again, we want to get x by itself. So you want to get everything away, move everything out of the way to get it away from x. So subtract 2. Negative 20 and negative 2 is negative 22. And then we're ready for step 4. Multiply or divide by whatever number is attached to x. 2 is being multiplied to x, so let's divide by 2. You're going to notice here, x equals negative 11 is one solution. There is one solution, x and negative 11. That's the only thing x could be. X is going to be equal to negative 11 because that's the only thing that makes this equation true. You're probably thinking, well, why are you bringing up one solution? Because as we flip over to the back page, we're going to find out that sometimes you don't have one solution to an equation. Sometimes you're going to have some special circumstances. In fact, sometimes you're going to try to solve an equation, you're going to find out it has no solution. In other words, no solution is when no possible value for our variable can make the equation true. Now, sometimes it's going to have, an equation is going to have infinitely many solutions. So no solution, that's whenever the left side will never equal the right side. When you can't make it work, that's no solution. Infinitely many solutions is whenever the left side is the same as the right side. So they're mirror images of each other. So if you have x plus 3 on the left, or how about this example? Infinitely many. Here's an example. Infinitely many solutions. X plus 1 will always equal x plus 1. If you try to solve this, everything is going to cancel out. You'd be left with 0 equals 0 if you tried to solve this out. So that is infinitely many solutions. That will always be true. Unlike no solution, which is what's going on down here. X plus 1 will never equal x plus 2. In fact, let's work it out. Let's try working this out. So I'm going to subtract x over. Wait, that cancels, that cancels. I'm left with 1 equals 2. That's not true. 1 does not equal 2. That's not true. So that is a no solution. So guys, what I'm going to let us do is let's practice one of these together. In fact, let's practice a couple together. And then we'll kind of be ready to start wrapping up. So step one, we're going to solve each equation if possible. Do we see any parentheses? Nope. So we're ready to combine variables together. So let's see, we've got, negative 3x and 6x. Those are on the same side of the equal sign. We can smash those together. So negative 3x plus 2 plus 6x, so negative 3x and 6x, that gives us 3x plus 2. Now, some of you guys may think, wait, I think I see what's happening here. 3x plus 7 will never equal 3x plus 2. These two sides will never equal each other. But if you don't realize that, no matter what variable x is, x could be any number, and this left side will never equal the right side. But if you don't recognize that, then how about this? Let's keep solving. Step 2 continues. We're going to combine our variables. We got a 3x here and a 3x here. Subtract 3x over. Oh no. Watch what we're left with. 7 equals 2. Well, that's not true. That can never happen. So this equation has no solution. There is no value of x that will make this equation true. How about number 2? Let's try it again. So we have t over here, negative t and 2t. The problem is that t's on the left side while these two t's are on the right side. So just like last time, we'll combine them. Negative t plus 2t, t plus 8 equals, that's 1t plus 6. And again, t plus 8 will never equal t plus 6. There is no way for the left side to equal the right side. But if you want to, you can keep working. You can subtract t, cancels, 8 equals 6. That's not true. That's not true at all. That is a no solution. I'm going to do one more with you guys, and then I'm going to give you a chance to flex on a couple of these to see if you can find out whether we have one solution, no solution, or infinitely many. Let's do one. I'll give you a little spoiler. Let's do one that's going to have infinitely many solutions. That's what that word identity means. Infinitely many solutions. So let's start. So step 1, all right, we got some parentheses. Let's go. 4 times that, 4 times that. 12m, 4 times 4 plus 16 equals 2 times 6m, that's 12m. 2 times 8 plus 16. Hey, check it out. The left side is the same thing as the right side. They're the same thing. If you see that, we have infinitely many solutions. If you were to work this out, subtract 12m over, you'd end up with 16 equals 16. If you were to bring that 12m over, which is always true. So infinitely many solutions. That means that no matter what variable you choose for m, whatever number you choose, and you plug that into both, the left side will always equal the right side. So I'm going to let you guys try numbers 2 and 4. See if you can do 2 and 4 for me, please. All right, back to number 2 here. So you're going to see I went ahead and combined the like terms on the left side that we had and combined the like terms that we had on the right side. So 7x minus 3 equals 7x. Now some of you guys probably got a little confused here. Well, number 1, this left side will never equal the right side because you will always be 3 less on the left side no matter what number you plug in for x. But let's say we didn't realize that and wanted to keep solving. Well, that would require us to combine our variables. So if 7x is over here, I'm going to bring it over here by subtracting it. Well, that leaves you with negative 3 on the left side and nothing on the right side. Well, what number do we use to represent nothing? 0. Will negative 3 ever be 0? Heck no. That is a no solution. Now, some of you guys are probably going to call me a goober on number 4, and spoiler alert, I am a goober. But we can distribute step 1. Negative 2 times j is negative 2j. Negative 2 times negative 3 gives us 6 equal to, we got negative 2j plus 6. And a lot of you guys said, wait a minute, Mr. Harris, this is the same thing on both sides. It's an infinitely many solutions. Right, and you're correct. I just wanted to show you what would happen if you didn't recognize that and you kept working. So we add 2j over to combine with this variable over here. Negative 2j and 2j add out. So you're left with 6 equals 6, which is always true. So no matter what variable number you choose for j, it will always give you a true statement. So thank you very much, guys. If you have any questions, you know how to reach me. And let's make sure we are becoming masters of multi-step equations as we're heading into our test after day 10. Thank you, guys.